is actually a 40 minutes presentation, so we will have to be quite fast. So my name is Zbigniew Łukasiak. I work in this company, and this will be a presentation on dependency injection. It will be mostly an introduction, mostly explaining what it is and giving your indications that it is actually something very straightforward and something that very much fits into the way that we have always worked as programs. So, first question, what would you do with this code? So let's say you see this in an application that you inherited from your from another developer. So you see this inside, somewhere inside the application. What would you do?
Not show it to Getty.
Okay. So, any ideas?
Well, as long as it's a test user, I don't care.
Well, actually, let's say that it's a real user. Okay. First, I will copy your credentials. Sorry?
So, I mean, I don't want to say what your talk's going to be, but the first thing that you get before the dependency injection is you probably make that configuration somehow.
Yes. So that was what I was asking about. So basically, when you see something like magic constants inside your code, deeply in your application, then the first thought of many programmers, well, at least by previous presentations, it was easier to get it from the audience. But the first thought is usually to take it out from the code of the application into some kind of configuration. So you can do this in many ways. You can put it into some header files, you can put it into some configuration that is written in the same language as the application. You can put it into some ini files or stuff like this. But basically, you take it out from the application and put it into some other place. So, why do you do this? So, the first thing is that it is this kind of configuration is very often needed to be changed. Yes. So, for example, you change the host, you change the user, you copy the application to some other place and stuff like this. And in all these cases, you need to change the constants. And if you have these constants inside of your application, then you need to dig it where it is and change it directly in the code. And for example, if you are not longer the maintainer of it, and then it gets complicated. Or if, for example, the code is taken over by an administrator who is not really a programmer, and maybe he doesn't know the host language of your application, but he knows how to write ini files. Yes, so when you move it out, then the administrator can take over the task of running the application. Yeah, and he can move it around, modify some how it works. And the point is also that you need to change it independently from the code of the application. So that's like the reason why you can move it out and why it really makes sense. So the other points are why you want to move it out, and you can move it out because you can change it independently from the rest of the code. So, for example, what if the code that you moved out, so you have it somewhere in some ini file, yes, so and the code was about connecting to the database. And then at some point you want to change it to have to add this attribute raise error, for example, or I don't know, transaction something or something else. So basically, you can complicate the ini file just inventing some additional syntax for this additional attributes, or you can make it more. You can leave the config file in Perl and just add this raise error, and then it becomes some kind of object-oriented config file like this. What you get from the config is it's not constants, but you get the connection to the database. And that's the beginning of dependency injection. Yes?
This is a problem you have with ini files or some other simple config file formats, but why not YAML or JSON?
Yeah, sure. Well, whatever you want. So, but the idea is that you move it out from your application, you put it into some file that is separated from the rest of the code. So that's the idea of
said about keeping the config file as Perl.
yes. So if you have additional needs, like for example changing the attributes or making it more powerful, like I don't know, running some code at the point of making the connection to the database, then you will need to keep it in Perl. And then it becomes some kind of config-oriented object-oriented config, because what you get from the config is an object. It's the database connection, not the constants like the password and the host, but what you get is an object, database connection. So, and that is like the beginning of dependency injection. So we will get into my definition of dependency injection later, but that's the intuition that, in my opinion, leads into dependency injection. So, yeah, so why would you do it? Well, for the same reasons as before. And why would you do dependency injection? So my opinion is that for the same reasons as you do configs. But not only, there are some additional reasons also. Okay, so what is dependency injection about? Is about decoupling, minimizing code dependencies. So we have this code above. This is an excerpt from a library from CPA. So we used this library, and fetch was a method. So we had this problem that it was using this PLPW2013 user agent, and we needed to change this into paranoid agent. Something like this. Well, basically make it more secure. Because LWP user agent, the standard agent, was not secure enough for us. So we wanted to use a substitution for this. It's called paranoid agent or something like this. And the problem with substituting this inside this code is that we could do this only by inheriting, by subclassing this code and then overriding this whole method. Yes, so subclassing and overriding the method. So that was the way that we could do this. But should the author of this library use dependency injection, we could do this simply by passing into the code, by making it a parameter that is explicitly passed into the code. So this user agent becomes a field in the object that we are using, and then at the creation time, we just pass the user agent that we need. And then we don't need to subclass it and to override huge methods, because the fetch method it was actually much longer than what I have here. So in this way, with dependency injection, we need to change the code in much less, and we don't need to cut and paste huge parts of code. Yes? Any questions? Is this understood? Because okay. So you can also look at this as if this LWP user agent was a magic constant in this code, because it is something that, well, we needed to change, but it was hard coded into this library that it can only use this LWP user agent, and we needed to use something else. It's like a magic concept. It's like hard coding the host name or hard coding the username or something else. So you can look at this also in this way. So formally, the dependency injection decreases the rank of coupling from control coupling into data structure coupling. Data structure coupling, it means that you pass the parameters in, that the information that you want to pass into the object, you pass it as parameters into the object, and you don't need to controlling the object. And we move the object construction code from our business logic into some other place, and then it becomes more universal. So the point is that here, this object constructor, this object construction, LWP user agent new, it's called inside business logic. And this is what makes it inflexible, because when you need to change it, you need to subtract and override big methods with copy pasting this whole method and just changing this small part. So if you move this object construction outside of it, then this code becomes more flexible. And it also becomes easier to test. And testing is how dependency injection was first discovered or thought up. Yes, so because it was simplifying testing, and but the underlying mechanism is actually more generic, more general, because it's about decoupling, and decoupling decoupling makes testing easier, but you can also but it also improves other parts of the code. Other aspects of the code. So there's one small disadvantage of moving this outside. This is because most users will still use LWP user agent. So if you move this object constructor outside from the library, then every user of your library would have to call this LWP user agent new. And then, well, you add some work for most users of your library. So this is the disadvantage. Your advantage is that you make your library more flexible, but at the cost of adding some work for the most common users of your library. So this is a workaround for this. You just use default. So defaults are like something that is a compromise. Yes?
So default might be a magic constant.
Yes. So in default, you use the magic constant. So most of the users are happy. They don't need to call new, to call LWP user agent new. So for them, they don't have this additional work. But the people that do need to change this user agent, they still can do this. And so there is another aspect of decoupling. When you use something like when you use singletons. And singletons you use mostly in big applications where you have parts that are used everywhere, and then, for example, configuration. So it's quite common that you have something like my application config, and then you get the port from this config. And then if you have a method in your code like this, then you cannot put it into CPAP because it uses this your application specific singleton. Yes. So singletons are always like this. They anchor your code to something else and make it less flexible. So what you do in this case, I don't have how you change this, but you change it in a similar way. You just make another attribute, port, and then you pass the port into the constructor and then use it as an object attribute. Instead of getting it all the time from the singleton, you pass it into the constructor. Okay, so the main reason to use dependency injection is always testability. So the point is that, for example, if you have this code with LWP user agent, and then you need to test how it works when the connection fails, or how it works when you get 404, or how it works when you get some different connection error, yes, something that doesn't happen very often. So for this, you would have to maybe make your own LWP user agent and override the namespace. That's possible. That's the mainly patching. But then you would override it in the whole application. That's kind of not very well. It's not very safe because it might be used in some other places independent from this code. And then, if you use dependency injection, then you pass just a stub user agent that always returns 404 or some other connection error. And then you can easily test how your code works, indicate when this happens, when you get some connection error. Yes? So there is a metaphor for this. So when you want to test a tire in a car, then, for example, you want to test this tire if it works in -40. So you can take your car into, I don't know, Antarctic, and then you have the -40, you can drive it around and check if the tires works okay. But well, in most cases we don't do this in this way. We just take the tire out from the car and put it into a laboratory where you can create the environment to test the tire that has the exact parameters that you need. And if you, so unit testing is like this. So you make a laboratory to test your objects, where you create the exact environment where that is exactly what you want to test. Yes, so the environment has like raises connection errors that you want to test. Just like in a laboratory, you can make the temperature -40 easily. So it's the same thing. And then, of course, it's when you test a car, you also need to drive it around, not only test in the laboratory. So the point is that with your code, you need also both kind of tests. You need the unit tests and you need the functional tests or system tests. But for unit tests, you need dependency injection. Okay, and then, for example, if you cook, then it's like a good method to start cooking is to prepare every ingredient so that it is readily available, and then you can start cooking. And then this way it makes it easier, like, to concentrate on your cooking. You don't need to measure the ingredients while you are cooking. You have everything available. And this is the same thing when you do the dependency injection. You create the objects before you use them in the business logic. Yes? So when you think, well, it's also similar with tools, like, I don't know, if you are a carpenter, then you sharpen your, how should I call this, saw. Your saw before you start your work. Yes, so then you can concentrate on cutting the wood and not on sharpening the saw. Yeah, that's what I said. And then, so my point is that dependency injection is something very natural for programmers because it goes directly from the things that we do quite automatically, like moving constants into config files. So why is it so elusive concept? So I think that maybe the name is not very intuitive. It's just something that is inserted somewhere, but
SQL injection.
Yeah, where is this injection? The original article by Martin Fowler wasn't very clear, and so and when you explain it like I did now, then people say that there is nothing new, but I would say that it still warrants a name because it makes the communication easier when you say, okay, let's use dependency injection here instead of explaining what you exactly need. Yeah, and it is often confused with libraries that you use for dependency injection. You can do this by hand or you can use special libraries for this. And you can use it in Perl. Many people think that it is only for languages with strong typing, but in Perl you can use it as well, with some additional work. And why you need this additional work, I will just explain. So this is my definition of dependency injection. I will read it. Dependency injection is a programming practice in which objects, since their creation, keep all needed dependency in their attributes. So everything they need for their work, they have in their attributes. They don't create anything while working. Instead of creating these dependencies in business logic or using globals, all dependencies are created on the outside and passed into the constructor, and so that then the object can use it. This object, and then when we move this object creation code outside, then we also need some place where we put it in. So this object construction code removed from the business logic becomes a separate part of the application, one that creates all the objects and then wires them up. It needs to traverse the tree and graph of dependencies and recursively construct the layers of the objects. So I think it's the next slide. So when you have objects with dependencies, they usually make a tree or a graph, because some objects can depend on objects that were already used somewhere else. So when you create this, you need to start from the leaves, the objects that don't have any other dependencies. You create them, then you create the objects that depend on them, and then you can create objects that depend on the objects that depend on the leaves, and so on, in a recursive way. So what the wiring does is it walks this graph and creates the objects. And it can be automated in many cases. And this automation stuff, it's called dependency injection container. The code, the extracted code, this object creation code, is very hard to test because it has lots of dependencies. You cannot unit test it. It's quite hard to follow also, so it's the you move it out from your business logic, so you simplify your business logic, but the place where you put it in becomes very difficult to follow and full of hard stuff. So it's useful to automate this and to make this part of code as simple as possible, as straightforward as possible. Yeah, so in languages, I don't know if I have a slide for this. In languages with strong type, then it's quite common that when you have an object without dependencies, then the type of the object defines it. You can create this object, just knowing its type. So when you have another object that has a constructor with arguments that have types, then you can create the arguments. So it becomes automatic. Okay? How to explain it? For example, if you have an object like it's hard to yes, so actually most objects always take some parameter, but let's say you have an object that is like cow, some stupid object, then you can have only one cow in your program. So it's kind of singleton. Then creating it, it's just calling you on this. And then if you use this cow somewhere else, then you already know how to create the cow. So you also can create the other object that depends on the cow. Yes. So in languages with types, then the type of the parameters passed into the constructor defines how you can create the object. Okay, maybe I should make another slide. Anyway, types simplify this. In languages without types, like in Perl, it is a bit harder because you need to define everything, every connection between objects by yourself. And then sometimes you still need to to create objects inside your business logic, like in loops. So, but it is also quite often that you can also make some workarounds around this and get rid of this. So in this case, I had this text feature analyzer, that the text feature counter that was counting stuff from a text, and the thing was that I was saving inside this object some statistics. So when I call this analyze, then the object stats were saved inside this text feature count object. So then I could use it somewhere else to do something with the stats. But this is conflicting with dependency injection, yes, because I call object creation inside business logic. So what I did in this case, I made an object that was immutable, and I was I made this feature counter object that was an attribute now, and I added this analyze method to this, and then it was outputting some result object. So immutability makes dependency injection, in this case, made this code compatible with dependency injection. It let me remove this object creation outside. Yes. If you have in your business logic objects that change when you do stuff, right? Then you cannot often you cannot move this object creation outside. But if this object doesn't change, then it can be an attribute and you can create it outside. And immutability is often beneficial also for other things. Okay, so it's always a trade-off. But okay, let's not go to these details because we don't have much time. And the last thing that is very important in dependency injection is scope. So for example, in web applications, we have two scopes. The first scope is application creation time. At this time, you can create. At this time, you can create stuff like database connection. And then is the request time, when you create stuff like request object. Yes? So at the application creation time, you cannot create the request object because you don't have data for this. So in this case, you need two places where you create objects. The first place is this application creation type, and the second type is when the request arrives. At this point, you can create all the objects that depend on the request data. So this dictates how many dependency injection containers you need to have in your application. Okay, so here is an example. So this uses a singleton, database singleton, and in another place it uses a global, which is very similar to a singleton. And then we have a replacement for this, just to show how we do dependency injection. So instead of the singleton, you make an attribute, and instead of the global, you also make an attribute. So the benefits of dependency injection, first of all, is testability. This is where dependency injection was invented. And then you avoid globals, and everyone knows why globals are bad, including singletons, which are really globals. And it makes your code more universal, more flexible, because it is less coupled.
That's actually one of the big problems of code, that like everything is hard-coded, fixed functions and everything like that. So yes, please, take this serious.
Okay. Can you have dependency injection without dependency injection container? Yes, you can do this by hand, by using factories and stuff like this. And if you do, for example, if you have just one application, then in Perl, using using dependency injection containers, container libraries doesn't make sense. Well, for me at least. You can do everything by hand, and it will be much simpler than using the containers. But if you have like a full suite of programs, like an application that run, like for example, a web application, and then you have a cron tab job that uses the same configurations and some same objects than the application. In this case, it is useful to use stuff like breadboard or other dependency injection container libraries. So it is better to use the libraries than coding it by hand. If you have just one application that doesn't have cron jobs and other stuff that uses the same information, the same configuration or stuff like this, it does, for example, database connection that shares the database connection, then in this case it is easier to do it by hand. Okay, and then law of Demeter. So what I was telling here is that each object should have all the data that it needs to work. It should have it in the attributes. Yes? So that is like the idea in dependency injection. That the object, when it starts to work, it has all the application, it has all the information that it needs to work inside its attributes. And law of Demeter is like the other side, like the opposite of this. It says that you shouldn't pass too much information into the object. So if you take both, if you apply both rules, then it's like you should pass all the information that is needed, but not more than is needed. Yeah. don't have a slide for this, but law of Demeter says that, for example, if you pass if you pass a configuration object, yes, like we had this singleton, but you would also say, okay, so I will pass this configuration object. So law of Demeter says it's better to pass the port instead of the configuration object and then extract the port from the object. Yes? So you don't pass too much information because the config object, it has much more information that you need. You need just the port. So it says that it's better to pass just the port. So this is like two opposites, and then in the intersection you have the ID. Oh, yes. Okay, so questions?
The thing I find tough with dependency injection is you still specify an interface for the objects you want to use. And at least in the Perl world, that means you're telling it exactly which class. And like in your LWP example, you have to use LWP there because all the methods are going to use LWP methods. I mean, if you want to throw in like Mojo user agent, you're basically stuck. So I end up doing weird adapter things.
Yeah,
I know, there's just another level of...
yeah. Well, but the point is that if you use the container, that you can change it in the container somehow.
Yeah.
You can adapt this.
Yeah, that's just my big problem. I mean, it's not a problem, I get around it, it's just, it's the issue I run into.
Okay. Other questions? Okay, so there's one more slide with some links to online materials. So this Miszko Hever, he has very good videos on dependency injection. He works for Google, and very good explanations. And then this slide, this last link, it's something that is very complicated, and I still don't understand this last one. But this is something that I want to understand. So maybe you will explain it to me next time. Okay, thank you. Thank you.